Ayo. So since last vlog, I've made quite a bit of progress. The SDL API is remarkably easy to use. So getting on with that. Um, at this point, I'm at the same stage I was in with my Vulkan code. A little bit further ahead, in fact, because at the Vulkan code, I never managed to get instances working, at least in the game logic. I had a separate piece of code where I was playing around with descriptors where I did have instances working. But it's a lot further ahead, right? Which is making good progress. It's positive, at least for me. So let's have a look at it. Oops. Can I see here? I can move it. There we go. So I have here movement with mouse. I'm not happy with how I've implemented the mouse capture with SDL, so that is something I'm going to have to fix in the future. The keyboard works fine. Can move up and down. We can strafe, all of that stuff, all the fun camera things. And, renders multiple cubes, not a problem. And like if we look at how I've organized this thing, um, start with the assets. The last time I showed the code, um, um, I had only the basics implemented, right? So none of the STL, like all the STL logic only went up to getting a GPU. But this time I have now a renderer class and an application class. The application sets up some callbacks so that it can deal with quit commands and other window events. Right now, there's only one callback in here, which is we go in there. It's just a close callback. Okay. And similarly, there's a prepare scene, which will load up all the assets, which is generating the pipelines. Set the clear color, generate pipelines, get the mesh, the instances, texture, and then tell the renderer to send it all to the GPU. So the way this is set up to work is that while it's in this function, all of these objects lifetime is active. So it has to be called from within this function. The upload has to be done. Because if you don't, then all of these will be deleted and you have a use after free. So that something to be try and fix in the future. But the way it works right now is if I go into vertices, for example, I create a vertex buffer of the appropriate size, which is the size of the bytes of data, because the renderer itself doesn't care about the layout of the data. It cares about how much memory it needs to allocate, right? And then we add it to a stage data buffer or stage buffer data, which just carries the pointer, right? This one, we look at it. It's just a vector of spans. Spans is pretty lightweight, which is just a pointer and the size of that pointer. And then, so all of these functions, they work the same way, right? They all do very similar things, right? Here is the index upload or other creation. So you make an index buffer, we push it to the stage data. Same thing with the instance. Create the instance buffer, push it to the data, stage data vector. Same thing for the texture, we take the image data texture that comes from the file, create a texture of that size of, height, width, map count, multi-sampling level, though multi-sampling level doesn't get used, I think, when creating the texture. Oh, it does. Okay. Um, Forgotten about that. And then, we add it to stage texture data, and we create a sample binding similar to a vertex binding and the index binding, which gets used during the draw time. Right? And then we just call upload, which will create a transfer buffer of the combined size of all of our um, stage data, right? That includes the uniforms or like the vertex index, as well as the texture. So everything is in one transfer buffer, right? And the way I'm accomplishing this is I'm using this range fold left, which can maybe make it a little bit easier to understand by saying, right? So it folds left and just sums up all the sizes basically. Um, then it creates a transfer buffer of that size, of the combined size, and I upload all the all the staged information onto that, right? So we do the copy for the staged buffer data and then a copy for the texture data, right? And it's just a plain old mem copy, nothing special. Then we just offset so that the data pointer moves forward. And then once we've done the transfer, then we can create a copy pass, which is how SDL does these things, which is very similar to how Vulkan does it. And I believe to a degree, Direct 3D 12 does it, though I don't have a lot of experience with Direct 3D 12. Um, yeah, and then we copy the vertex buffer, copy into the vertex buffer, copy into the index buffer, instance buffer, texture. With the texture, it's a little bit special because there are mip maps on the texture that I'm loading. So you have to do a copy for each mip map. You have to upload each mip map individually. So you have to define the region where that memory will live, or region in the buffer where it should go to. All right. Now, when we created the buffer, we gave it the full size, but it's not square size. It's a little bit bigger. So this kind of fixes that. Because like if you look at the texture, it's, let's see. Let's kind of load that up here. Oh, what am I doing? I could do it from here. I guess I haven't set up VS Code to open texture files. So that's what a texture looks like. It's a 1024 by 1024 with 11 maps, so including the main file. Okay. I think there was a way to see all the layers. I guess it's not in this one. Yeah, so we do that and then we immediately just run the copy, which does the copy over. And then we go back to the application. Once that's done and the scene is prepared, I had to enable this to get the mouse movements to be relative, which is what I mean. I don't like how this is just hanging out here by itself. It should really be either in here or in here somewhere. I need to figure that out. Then we kind of just pump the events, update. So this update will look at your keys, right? Key presses. And if depending on what key you pressed, move the camera. So here's my camera movement, right? Um, yeah, so it's basic ASDF movement. Again, this is another thing I want to change in the future so that it's bindable. So it should really be acting on actions rather than direct button presses. But we'll get to it. Once the camera has moved around, we simply update our projection matrix, right? Which the draw command will take again as a span of bytes of a memory location basically and send to the GPU. Right? And the camera itself is not complicated either, because if I go in here, it's just a simple quaternion based camera, which then when you call get view transforms the quaternion into a little matrix. Okay, straightforward so far. A few changes I want to make. One of the items I want to change is this render file. It's very messy at the moment. It's also very hard coded because we're writing to these predefined buffers, but that's fine if there's only one mesh and one pipeline and one texture. That's not going to be the case, right? We will have multiple meshes with different instances. So I need to fix that. I have some ideas on how to do it, so which I will probably tackle after I get the skybox working. All right. So that's the next step, is getting the skybox or a sky dome set up using a cube map, which is very simple from my past experience because I did do that before. And a basic terrain rendering. So no optimization, just a plain grid. And then if I have more time, I will refactor the whole thing to be less coupled, right, with the renderer class to fix that. Okay, that's the progress for this week. That's it for now. Thanks.